Can you see the white row? Can you see
Yes,
that?
ma'am.
We have question related this topic. We have
Okay, ma'am.
d square d square plus 4y is equal to sine 2x, and we have here fd is equal to d square plus 4, and pi is equal to 1 upon fd
Okay.
uh, and sine 2x, and we need to put, and we have fd 1 upon d square plus 4 into sine 2x. Here we
Yes,
have
ma'am.
a is equal to 2. Okay,
Okay.
so
Yes, ma'am.
here a is equal to 2, then a square is equal to 4, and minus a square is equal to minus 4, and we need to put d square is equal to minus a square, which is minus 4. Now we need to put here. Okay,
Okay, ma'am.
then fd will become 0. Got it? Because we have
Okay.
minus 4 here instead of d square, and take this plus 4, then we will get a 0 in denominator. Then
Okay, ma'am.
since fd is 0, then we'll apply f dash
Okay.
on putting d square is equal to minus a square, we get fd is equal to 0. So take f dash d instead of fd. Got it? So now
Yes, ma'am.
pi is equal to 1 upon f dash d and sine 2x. So f dash
Okay.
d is, differentiation of this d square plus 4 is 2d only, because this is 0.
Yes, ma'am.
Yeah, so we have here 2d, 1 upon 2d and sine 2x. And we can't put here value of d because we use only d square. We put
Yes, ma'am.
value of d square only. So take as it's means 1 upon d is integration,
Yes, ma'am.
right? Integration of, sorry, this. Or you can take as an inverse also, then you can use differentiation. Got it? Either
Okay.
you can use 1 by 2, 1 up, because 1 upon d is always d is equal to d upon dx, differentiation, and uh, 1 upon d is integration. Okay?
Okay,
So
ma'am.
if we put this 1 by 2 here, and this 1 upon d is integration, this 1 upon d is integration, then you can integrate this sine 2x dx. Got it? Or you can use
Yes, ma'am.
directly 1 upon d as a integration. So
Ma'am,
1
but
by
why
2
can't we
and
put these value as A?
pardon?
Ma'am, why can't we put these value as A?
Because yeah, because we use a d square is equal to minus a square. Okay,
Okay.
when we take value of d, then it will become means imaginary part, and we use this only to solve for sine or cos.
Okay,
Okay,
ma'am.
that is
Yes,
why
ma'am.
when we get d, then you can use, you have here single d. If you have like you have here 1 upon d, if you have like d in terms of like d plus 1 or d minus 1 or 1 minus d, like that, then you can use as polynomial, you can take in numerator as an inverse, then you can solve by use this that formula. Got it?
Okay, ma'am.
If you're like 1 plus d or 1 minus d, whatever, in numerator. Then you can use 1 plus d inverse and take here
Okay, ma'am.
sine 2x, then expand by using binomial expansion. Okay, here we have only 1 upon d, and take this 1 by 2 outside of this symbol. This is constant, and integration of sine x is minus cos x. So we take cos 2x and by 2 by using partial derivative.
Okay, ma'am.
Got it? Yeah. So we have here minus 1 by 4 or cos 2x by 4 by multiplying this. Okay?
Yes, ma'am.
So you can do in this way. Now ask next.
No, ma'am, I just had this doubt because I was solving
Okay.
questions right now.
Okay, okay. That's great. So shall we start partial differential equation?
Yes, ma'am.
Okay. And in differential equation, either partial or just ordinary or higher order. We need to create means form differential equation, and another way to solve the differential equation.
Okay, ma'am.
So we have some notation. I'm telling you how can you use to form differential equation or to solve differential equation. Here we have a partial differential equation. Let z be a function of x and y, then we can differentiate z with respect to x as or with respect to y as. So we write means we can replace this partial derivative by using this small p, and this is small q, and second order derivative is with respect to x is r, and s is second order derivative of z is this del x del y, and this t is equal to del square z over del y square. We use these symbol
Okay, ma'am.
to form a differential partial differential equation. And we have a like question, uh, form, form the equation x square y square, okay, x square plus y square plus z square is equal to 1 from, sorry, form form a partial differential equation. They can give you in short form PDE. This is partial differential equation
Okay,
by
ma'am.
eliminating arbitrary constant. we will form a PDE by eliminating this one, and let's form it. First of all, we need to find these derivatives by using this equation by differentiating this z with respect to x and y.
Okay, ma'am.
Okay. So first of all, we can write this equation in terms of z like this. We have solution x square plus y square plus z square is equal to 1, and we can write this entire equation in terms of these, taking z on left side, and 1 minus x square minus y square. Now differentiate this equation with respect to x. So by using power rule, we take this, I don't know, first 2z del z over del x is equal to del. Are you getting this point?
Yes, ma'am.
Yes, ma'am. Okay. And del over del x of 1 minus x square minus y square. So we have 2z del z over del x is equal to 1 is 0, and
Yes, ma'am.
differential, yes, of this 2x and this is 0. So we have del z over del x is equal to minus 2x over 2z, or del z over del x is minus x upon z.
Okay, ma'am.
Next, similarly, we'll get del z over del y. We can write because we have here to minus y square also. Then we'll get the same.
Yes, ma'am.
Okay. Yes, ma'am. Can I write direct?
Yes, ma'am.
Is we'll, yes, use here minus y over z. So del z over del y is minus y over z.
Okay, ma'am.
So okay, this is, or from here we can use this is value of p. You know, this is, we use p according to the symbols.
Yes, ma'am.
Del z, yes, over, yeah, and this is q. So here we can write this from here. P is equal to minus x over z, or which gives from here mm, z is equal to minus x over q.
Okay, ma'am.
Okay, ma'am. And from here q is equal to, because this is q, so
Yes,
q
ma'am.
is equal, yes, to minus y over z, and from here z is equal to minus y over q. So here z is equal to minus x over p is equal to minus y over q, and we eliminated arbitrary constant from here. So from here we can take these are equal.
Yes, ma'am.
So take, yes, this minus x over p is equal to minus y over q, and we can cancel this minus sign, and x over p is equal to y over q, or qx is equal to py hat, and this is required PDE, or you can write qx minus py is equal to 0.
Okay.
You can write, okay, this is this or this, both are required PDE, partial differential
Okay.
equation. Okay. You can write any form, either this or this. Okay.
Okay, ma'am.
Okay. And let's do some more question. question, from the equation, x upon 2 plus y upon 3 plus z upon 4 is equal to 1, form a PDE by eliminating arbitrary constant.
Okay, ma'am.
So we have this equation and we need to form a PDE. So let's do. We have this equation x over 2 plus y over 3 plus z over 4 is equal to 1. And z over 4 is equal to 1 minus x by 2 minus y minus 3. Now differentiate with respect to x, del z over del x, and take 1 by 4 here
Yes, ma'am.
is equal to, this is 0 and this also 0, and we have minus like del, so del x of take 1 by 2 here, minus 1 by 2, this is of x, and this will become 1, or we can write direct term.
Yes,
Did you
ma'am.
get it? Because differentiation with respect to x, so this is 1 by 2, and from here del z over del x is equal to minus 4 by 2, or you have um, 2, and this is p.
Yes, ma'am.
And let us, and now let us find del z over del y, which is equal to uh, this is minus 1 by 3.
Yes, ma'am.
So this is q is equal to, and this is also 1 by 4 here, because we have here z value. That's it.
Yes, ma'am.
And we have here minus 4 by 3, and equal to minus 2. So from this and this we have P is equal to Q, and this is the required PD.
Ma'am, could you
This, yeah, this was XY2 and YY2 and plus ZY4 we have here.
so ma'am, you've changed the question, right?
Yeah, yeah. This is little. This was little bit blur, so I thought this is YY3 like this, and this was YY2 only. Yeah,
Okay, ma'am.
yeah, YY2 here, and here YY2, and take this. So we have here minus 1 by 2, and we have here P is equal to minus 2. And similarly, we have here when we differentiate with respect to y, then we have minus 1 by 4 on left side because we have z by 4,
Yes, ma'am.
and on right side minus 1 by 2, and both p and q have the same value. It means p is equal to q, and which is required pd.
Yes, ma'am.
And let me check another method to help your students to PDF in it.
Yes, ma'am.
This is way to form PDE. Okay, so now I'm checking the next method. So just give me a minute.
Yes, ma'am.
The topic is classification of second order partial differential equation. So we are going to start this.
Okay, ma'am.
Give me a moment. I'm just opening the material.
Yes, ma'am.
classification of second order. Yeah, tell
Ma'am, your
me.
screen is not visible.
Okay, let me share it again.
Yes, ma'am.
Can you see now?
Yes, ma'am.
Classification of second order partial differential equation. First is second order equation in two independent variable. Equation in two independent variable. Second is canonical forms. Third is equation with constant coefficient.
Okay.
And next, fourth type is general solution. Mainly the general solution of all. So mainly we have these three types of PDE, partial differential equation. Second
Okay,
order
ma'am.
in two independent variables, canonical form, and equation with constant coefficient. Okay. So first of all, we learn um, this one. Type first is second order partial differential equation in two independent variables. general form is general form for linear section of the PDE. General form is we have A into d square z over dx square plus b d square z over, sorry, del square z over del x square and del square z over del x and del y plus c
Okay, ma'am.
del square z over del y square and plus d del z over del x plus e del z over del y plus f plus g, sorry, plus f into z plus f into z is equal to g. Or we can write this equation in this form of a z x, x means this is second order derivative with respect to
Yes, ma'am.
x, plus b x z xy plus c z y y plus d zx only with respect to x plus e and z y and plus f is equal to 0. This is the general form of the second order PDE.
Okay, ma'am.
And we can classify the equation of ellipse, parabola, or hyperbola by taking this. Hmm. Find then um, b square minus 4ac. b square minus 4ac discriminant
Okay.
if b square minus 4ac is less than 0, it means if we get negative, then equation, then the given equation is elliptic.
Okay.
With help of this general form, we'll find this b square minus 4ac. Okay,
Okay,
and
ma'am.
then find if this is less than 0, then this given equation is elliptic. And next one, next condition, if b square minus 4ac is equal to 0, then the given equation is parabolic.
Okay, ma'am.
And if b square minus 4ac is greater than 0, then the given equation is hyperbolic.
Yes, ma'am.
So in this way we can show, we can classify the equation. Let's do some question related to it. Give me a minute, I'm just I'm just sending you some questions, and we'll do some question out of them, and some more you can do as a practice. Okay.
Okay, ma'am.
Wait, I'm giving you some questions.